once again, because you've been the person who has created all this amazing, content. With reference to, Bharat had mentioned about how the imbalance of data is kind of taken care when we are dealing with ensemble techniques. So, can you explain a little bit about how the various methods, or what does it do to take care of the imbalance or extreme imbalance if it is there? The
Sure.
ensemble.
Sure. So if you have imbalance in the data, and if you are going to, split the data only once and get the training data and then build a model on the training data, then chances are very high that if you have, say, for example, 90% as default in this underlying data set, and say another 10% is, 90% not default and 10% default. In this case, when you just split it once, chances are very high that your data might be biased in a sense. Maybe 90% of data is default, not default, another 10% is default. So you're training your data heavily on not default scenarios. But when you keep splitting it multiple times, and then when you actually build on all these different samples, then chances are bleak that each time when you take, your underlying data would have more of not default and less of default. Right. So this is how your ensemble techniques will counter the imbalance in the dataset. And also when you perform certain other techniques such as stacking, etc., you couple that with cross-validation techniques, so that even if you have that imbalance in the dataset, you ultimately end up building your model on every observation, more or less every observation. And you also end up testing your model on more or less every observation, right? So given this logic, ensemble techniques will help you avoid, building a model which is very biased. And that is how it handles the imbalance in the data. Yeah.
All right, Bharani.
Yeah. Over to you, Nitin.
Yeah. So I think we just have a minute left. So I think we'll wrap it up a little early. So yeah, that's the thing about